Hello everyone. So today we will discuss about the correlation matrix. So before discussing about the correlation matrix, what is multicollinearity? It refers to a situation in a regression analysis where two or more independent variables are highly correlated with each other. Okay, now a correlation matrix is a table that shows the pairwise correlation coefficients between variables in a dataset. It is used to understand how each variable relates to every other variable in the data set. Now, what is a correlation coefficient? The correlation coefficient is a statistical measure that describes the strength and direction of a relationship between two variables. It is a value it has a value between -1 and 1. Plus 1 indicates a perfect positive relationship as one variable increases, the other also increases. Minus 1 indicates a perfect negative relationship as one variable increases, the other decreases. 0 indicates no linear relationship between the variables. How is correlation matrix structured? The correlation matrix is typically square, having the same number of rows and columns because it shows the correlation between each pair of variables. Second, each cell in the matrix represents the correlation between the variables corresponding to that row and column. The diagonal element from top left to bottom right will always be 1 because each variable is perfectly correlated with itself. This last point we will see in our output of the code. Now we will see the code of a correlation matrix. Correlation matrix. One way to identify multicollinearity is by examining the correlation matrix between independent variables. High correlation coefficients indicate potential multicollinearity. So here is a Python code that creates a heat map to visualize the correlation matrix of a dataset. Heat maps are a great way to quickly understand relationship between variables and data. We will be using a pandas, numpy, seaborn and matplotlib libraries. Pandas for data manipulation, numpy to generate random data and seaborn to plot heat maps. Matplotlib for the actual rendering of plots. Now creating a data frame with a random data. np.random.randn 100 is used to create 100 random numbers from a normal distribution, mean equal to 0 and standard deviation equal to 1. We will organize this data in a pandas data frame where each feature will represent a column. Now calculate a correlation matrix. Now we will calculate the correlation matrix by using the df.core function that calculates the pairwise correlation of all numeric columns in the data frame. Now creating a heat map. Now the heat map, the correlation, we will use the parameters correlation matrix and not equal to true. This adds the numeric values to the cells. Now CMap equal to cool warm defines the color palette ranging from color blue to warm red. This indicates the formats the number to 2 decimal for better readability. Now plt.title is used to give the title to our plot and plt.show help us to plot the display. So here is the output. When we run this following code, we get this following output. In this correlation matrix, we can see that diagonal elements have a 1 value. They have 1 value because feature 1 is perfectly correlated with itself. That is why the value is 1. So we have learned how to create a correlation matrix, visualize it with a heat map and interpret the results. Heat maps are a powerful tool to quickly grasp the relationship between variables in our data. I hope this is clear to you. Thank you for watching my video.